Hey everyone, so now we are moving into understanding the complex number system. So this video is a little long because it's 2 lessons in one. We're going to try to speed up because we are behind in our curriculum. So we're going to do the do now during our Google Meet instead. Alright, so just quick review, solve these. Alright, so the first one, x minus 4, x plus 3 equals 0. So x equals 4, x equals negative 3. 3x squared equals 4, so x equals plus or minus 2. Let's see, number 2 looks like 2x minus 3, 2x minus 3. X equals 3 over 2. Okay, so what if we had that? What would we do? So we can take the square root of both sides. X equals, the square root of 4 is 2, but then we have that negative, right? And we said before, there is no real solution. However, so what mathematicians do is if they can't figure out a way, they make something up. So what they did was they made up something to represent the square root of a negative so that they could deal with that when they're solving problems. Because that's a simple equation that we just can't solve. So they replaced square root of negative 1 with the letter I. Why aren't you erasing? All right, I'll just write it in. The square root of negative 1. And I is always written with a little tail. So the square root of negative 1, they basically are just replacing it with a letter, and it makes it easier to deal with. So this is the complex number system. So we always write our numbers A plus BI. A plus BI. So it's the A and the B are real numbers. So the A is the constant part, and then B is just the coefficient of the I. Okay, so how would we write each of these then? So number 1, the square root of 9 is 3. And because we have that negative, we're just going to write an I. Because imagine it's really the square root of 9 times the square root of negative 1. All right, so that's 3 and then times I. All right, so pause the video and do the other ones. So we got 10I, square root of 100 is 10. That negative doesn't go away, so negative 7I. This one we can simplify, that's 4 times 10. So 2. Now I'm going to throw that I in, root 10. Don't leave the negative underneath. Oh, and the I always goes in the front. This is 25 times 2. So, and then we have our, right, square root of negative 1. So I'm going to do plus or minus 5, that's square root, and then root 2. And then the last one, you can't simplify. It was a trick question. 35 is just 5 times 7. You can't do anything there. All right, so pause the video and solve these. So number 7, I can move the 64 over. So x squared equals negative 64. Square root. Remember, when we do a square root, we need plus or minus. Square root of 64 is 8. We have a negative under the square root, so we have an I. Now, we can't factor this, right? So we have to use the quadratic formula. You could also complete the square if you want. It's up to you. I think completing squares is slightly easier, but I'll do the quadratic formula for you. All right, so negative b plus or minus the square root b squared minus 4ac all over 2a. So 4 plus or minus 16 minus 32 is negative 16 all over 2. So that then we get 4i over 2. So x equals 2 plus or minus 2i. All right, 2 more. Again, quadratic formula. Easiest way to do these. Alright, so I got x equals -5 plus or minus the square root 25 minus 4 times 11 all over 2, -5 plus or minus, let's see, that's 25 minus 44, 19, -19. So for that one, all I'm going to do is replace the negative with the I. So x equals -5 plus or minus I root 19 all over 2. And that's my answer. I'm not going to do anything else there. All right, next one. Can I divide? I can't divide by 3. Okay. So I'm going to have to do the work. -42 plus or minus the square root 42 squared minus 4a c all over 2a. Ugh, definitely need a calculator for this one. Let's see what we get. Alright, I got -240. Let's see, 240. I know it's not going to be 4 and 60. Because 4 goes into that, so 16. 240 divided by 16, 15. Alright, so it's 16 and 15. So then I get x equals -42 plus or minus the square root of 16 is 4. We have that negative, right? So I'm going to put an I, root 15, all over -6. And then finally I'm going to divide everything by 2, or -2, it doesn't matter. I'm going to do -2. So get 21 plus or minus 2I root 15 all over 3. And that's my final answer. So it's just quadratic formula. Okay, so now this is super easy, guys. Pause the video, do what you think you're supposed to do. It's literally combining like terms, right? So it's knowing how to add numbers. Try to avoid calculator. I usually don't give a calculator on this quiz, so try this without a calculator just so for practice. So combining like terms, -9 plus 6 and 5, 11i. The next one, don't forget this is a negative. So what I'm going to do, I usually just distribute the negative. So I get -42 minus 19i. And then this last one, we're going to rewrite it because what's the square root of -36? So this is 19 minus 6i plus -2 plus 11i. So then I can combine like terms and I get 17 plus 5i. All right, so now we're getting into, this is the second lesson now. So remember, what was I equal to? The square root of -1. So what do you think I squared equals? I squared would be the square root of -1 squared. What does a square root and a square? What happens there? They undo each other. So you get -1. This is definitely something you want to memorize. I squared equals -1. That's super important. Just like this is super important. All right, so what do you think I to the third is going to equal? Well, I to the third, how could we that's -1 to the third, or we could rewrite it like this. I squared times I. But what's I squared equal to? That's -1 times I, so we get -I. What would I to the fourth equal? Well, I to the fourth would be I squared times I squared, right? Because we add our exponents. What's I squared equal to? So -1 times -1 equals 1. How about I to the fourth? Or I to the fifth? Well, I to the fourth was 1, right? So let's do I to the fourth times I. 1 times I is I. I to the sixth, pause, see if you can figure it out. I to the fourth times I squared. I to the fourth is 1. I squared is negative 1, so we get negative 1. So if you notice, all our answers are either I, 1, negative 1. And it's this cyclical thing, if you notice, because basically every I to the fourth gets pulled out, right? So let's say I had I to the 21st, right? Well, how many I to the, we're going to take out all the I to the fourths. I to the 4, I to the fourth, I to the fourth, I to the fourth, so that's 16, 20, and then one more. All of these are just 1, so we're left with I. Right? So here, write this down. I is just I, right? I to the first, I to the second is negative 1. I to the third is negative I to the fourth is 1. So that's kind of like a good way to memorize it. You could sometimes we could also include I to the 0. Anything to the 0 power is 1. But basically that's how it works. Every 4 i's we get rid of because I to the fourth is 1. All right, so I to the 32nd. What do you think that's going to be? We got to get rid of all the I to the fourths. So what happens when we get rid of all the I to the fourths? Do we have anything left over? We don't. So think of this is really just long division of numbers. So 4 goes in. What's our remainder? We have nothing left over. So we use I to the 0 is just 1. 71. We got to take out all the I to the fourths. So we're going to divide 71 by 4. Let's see, 1, 31. So that's 7, 28, 3. So we get rid of I to the fourth 17 times. So we're taking out 17 I to the fourths. And we're left with 3. There's 3 left over. So I to the third. And then what did we say I to the third equals? Negative I. All right, I to the 90th. So again, we're going to take 90, divide by 4. 2, 2. So we're left with 2. So we're taking out 22 I to the fourths, and we're left with I squared. And I squared is negative 1. I to the 37. Another way to think about it is just I to the 36th times I. I to the 36, right? That's a multiple of 4, so it goes away. So we're left with I. Or 37 divided by 4 is 9. We have 1 left over. I to the first is just I. All right. Go through. This is literally just distributing and then substitution. So I'm going to do the first one, and then you're going to do the rest. So 12i times 5i. Think of the I as like an x. So 12 times 5 is 60 I squared. But what's I squared equal to? I squared is negative 1. So what do we get? Negative 60. Right? So that's what you're going to do. You're going to go through, multiply through, and make sure you replace all your I squareds with negative 1, right? So pause and do all of that, and then check your answers. All right, so I get negative 12 I squared. That's negative 12 times negative 1, which is just 12. 4I squared. That's 4 times negative 1, which is negative 4. Negative 32i plus 20i squared. That becomes negative 32i minus 20, right? 20 times negative 1. Negative 132i minus 99i squared becomes negative 132i plus 99. And negative 30i minus 42i squared becomes negative 30i plus 42. Right? Again, replacing 42, the I with negative 1 over here. negative 99 times negative 1. All right, same thing, just FOIL. FOIL these out. Let's see, we got 20, 8i, 15i, 6i squared. So that's 20 plus 23i. And then this becomes 6 times negative 1, which is minus 6. And then we can combine like terms. So 14 plus 23i. So it's FOIL, substitution, simplify. FOIL, substitution, simplify. Pause the video, do this on your own. All right. Negative 20 plus 5i plus 32i minus 8i squared. Negative 20 plus 37i. And then this becomes negative 8 times negative 1 is plus 8. So negative 12 plus 37i. And the last one, negative 27 plus 63i minus 9i plus 21i squared. All right, I'm going to skip a step. So I got negative 27 and negative 21 gives me negative 48 plus 54i. All right, last slide. Try these on your own. Oh, wait, no, I think I'm lying. I think there's one more after this. There's one more after this. Just kidding. You can still do these on your own. All right. 4 minus 9i times 4 minus 9i. It's the exact same thing that we just did. So that's 16 minus 36i minus 36i plus 81i squared. That 81i squared is turned into negative 81. Negative 81 and 16. Use my calculator. Negative 65 minus 72i. Next one, 6 plus 7i. 6 plus 7i. So that's 36 plus 42i plus 42i plus 49i squared. 49i squared becomes negative 49. Combine that with my 36. 36 minus 49 is negative 13. So we get negative 13 plus 84i. That's it. All right, so now number 3. This is the hard one. Notice it's to the third. So what I would recommend is FOIL out the first 2 of them and then multiply that last one. So I'm going to do negative 2 plus 13i down here times something. And up here, we're going to do 2 of them. So negative 2 plus 13i, negative 2 plus 13i. So we're going to multiply those 2 together and then multiply it by 1 more. So 4 minus 26 minus 26 plus 169i squared. So that's negative 169 plus 4. So negative 165 minus 52i. All right, so now we're going to FOIL that out. Ooh. 165 times 2. 330 plus 104i minus 165 times 13. 2145. This one's gross. Minus 52 times 13. 676i squared. 6i squared. All right. So we end up with 330 plus 676 plus 330 is 1,006, and then minus negative 2145 plus 104, and we get 2,041i. 41i. Ooh. Well, that was a little ridiculous. All right, now this is the last slide. I lied before. This is actually a nice one. All right, so go through, FOIL, what do you get? All right, so again, just FOIL. 11 times 11, 121, plus 66i, minus 66i, minus 36i squared. So if you notice, the middle two terms cancel, and we get 121. And then here we get minus 36 times negative 1 is plus 36. So we get 157. So we multiplied two imaginary numbers, or complex numbers, and we got an integer. So notice that, that's important. And that's going to be the case in all of these, right? So we get 64 plus 24i minus 24i minus 9i squared. Middle two cancel. This becomes plus 9, 73. And then the last one, 4 minus 10i plus 10i minus 25i squared. Middle two cancel, and we get 4 plus 25, which is 29. All right, so it is a packet because it is a double lesson. So work on that, and I will see you later. Bye.